Okay, so Mr. Rups here. We're going to solve these quadratic inequalities and inequalities. So to start off with, I'm going to rewrite this algebraically, making one side to 0. And then I ask myself the magic question again. What two numbers multiply to get negative 36 and add to get 5? And if you think about it, you're going to get 9 and 4. The 9 has to be negative and the 4 is positive. And so I know x equals 9 and x equals negative 4, even though I'm concerned with greater than. I'm going to worry about that in just a moment. I'm going to make myself a number line. Well, here's negative 4, and here's 9. And so when I look at the negative 9, the number line, I'm going to choose a value that is in this region here of negative 4. Anything less than negative 4, so I don't know, a number less than negative 4 is negative 100. That's definitely less than negative 4. If I substitute that in for x, that is a negative value. If I substitute in for this x, the negative 100, that is also a negative value. And so I know that that is positive. So everything in this interval less than negative 4 is positive. Choosing a value between negative 4 and 9, well, 0 is quite a nice number. If I plug 0 in for x, that's a negative. If I plug 0 in for x here, that's a positive 4, a positive. Together, that makes a negative. And finally, when I look at bigger than 9, so let's choose a big giant number, 100. If I substitute 100 in for x, that is still going to be a positive value. If I plug 100 in for this x, that is still going to be a positive value. Together, that makes positive. Now, when I read this sign here, that means greater than 0. And the numbers that are greater than 0, this actually means positive values. So this question is asking, where are these numbers positive? Well, here they are positive, and on this interval they are positive. And so the answer to the question is x is less than negative 4, or x is bigger than 9. And so, and because specifically there's no equal sign here, there's no equal sign here. We don't want them to equal 9. All right, and so this is the interval where all the quadratic will be positive. Moving now to the other side, I am going to solve this one. And because these numbers here are fairly small, I'm going to try and do it by factoring. Now, the magic question will not work here because of the 2. But I do know that the first two numbers in these spaces have to multiply to get 2x squared. And the only option is 2x and x. The next thing I have to consider these two spaces here. And those two spaces have to multiply to get negative 5. And so my choices really happily is just 5 and 1, 5 and 1, and 1 and 5. So I'm just going to randomly put 5 and 1, and I'm going to do 2 happy faces. And I multiply, I get 5x. I multiply here, and I get 2x. And together, I can't combine them to get 9x is what I'm looking for. So that means I don't have the right combination. So let's switch them around. Let's make this 1 and this 5, and I double happy face. So this is 1x, the other one is 10x, and I ask myself, could I make a 9x? And the answer is yes. If this is positive and this was negative, I can get a positive 9x. So carry the sign back. This one's positive, this one's negative. And so then I know 2x minus 1 is 0. So x equals 1 over 2. Or x equals minus 5. And so those are my two scenarios. Now, if I couldn't factor and I didn't have a calculator, the only option there, the next option is quadratic formula. Or I could also convert it to vertex form and then PEMDAS backwards. Okay. If I have a calculator in hand though, probably the easiest way to do this one is if I go to my applications, and number 9, polysimultaneous number 1, it's the largest power is power 2, so x squared. So I'm going to, next is the graph button. I type 2 in. I type 9 in. I keep that, I always make that -5, and then I can hit solve. And you again can see x equals -1/2 and, or +1/2 and -5. And so those are just some of the techniques we have. When we have an inequality, we use this number line idea to find where it's positive.